Hi everyone, this is Dr. Dan. In this video I'm going to walk you through how I would approach the second Excel practice quiz. So this one deals with Darcy Lynn winning $1 million, but unfortunately it's spread out over 40 years. And so Excel is a great thing to do some financial calculations in. So we're going to do this. Hopefully by me doing it you can see what I'm thinking as I'm solving the quiz, and that will help you think better about how to use Excel. So let's jump right in. Okay, set up an Excel spreadsheet with some constant cells so you can change inputs. Okay, we want to input she's receiving $1 million over 40 years. So those are two things we're going to put in cells. Okay, and it says first we want to calculate how much money Darcy Lynn will receive each year over the next 40 years. Okay, so that's pretty easy to do. It looks like a fairly simple calculation. So we'll open up Excel and say prize money. We can put $1 million in there. And you can format this in dollar if you want, if you click the little dollar. Years. And it just wants to know money per year. And that's just a simple calculation. It is the total prize money divided by number of years. Okay, go back to the quiz. Okay, and this is basically telling you how to do it. In third cell, calculate how much money you should receive per year for the next 40 years. Okay, and do not overthink it. It's really easy. Okay, so $1 given to you 40 years from now is not the same as $1 today. It's always better to have the dollar now because inflation is going to eat away at your money. Okay, and yeah, things cost a lot more in the future. Okay, so we need to convert money into today's dollars. So we know how much that $25,000 40 years from now is actually worth. And so there's an equation that is given to do this. So we have an equation that says present value equals future value over 1 plus the interest rate to the nth power. Okay, and that's all this says. Okay, and it gives us an example. Let's say make our spreadsheet to calculate how much Darcy Lynn's winnings are worth to her today. Okay, inflation rate is going to be 2.6. Okay, it says make a constant cell in Excel. So we'll do that. Inflation. Oops. 2.6%. So if you put the percent sign in there, it recognizes it as percentage. You could also put 0.026 in there. It will treat those numbers as the same. Okay, and it says how much is the 40th installment of Darcy Lynn's $1 million worth today? Okay, so perfect. Let's go ahead and do this. We want to make basically a chart that shows how much her money is worth. So year is going to be, let's say year one this is the first year, so I'm going to make it equal to the first, how much payment she gets. Okay, and then in year two, so I'm going to actually make this plus 1, because we're going to want to do this. I'm going to drag this down for 40 years. Okay, so that's 40 years worth of payments. In year two, now we just need to put this equation in. Okay, so we need the original value over 1 plus the percentage to the power. Okay, so this is going to be the original value. So I'm going to do money per year. And so I'm going to put, we know we're going to copy this down, so I'm going to go ahead and put dollar signs in there, divided by 1 plus the interest rate, okay, to the power. And so this is 1 year, so we want to do the power. I think I'll just say, we know it's going to be to the power of 1, so I think I'm just going to say A9 minus 1, because then when I copy it down, oops, we want that to stay constant, right? The inflation rate needs to stay a constant as well. So it's all right if you make mistakes, is the lesson here. So we drag it down. Okay, and now that is a10 minus 1, so it's going to the power of 2. So that's what we want. I'm going to also make those dollars. You don't have to do that. It just makes it look a little prettier. So we go down. And so basically that's what this is telling us. Her last payment 40 years from now is only worth $9,187 in today's dollars. And that's what the question is asking. So we can put that value in. And I can just copy and paste, Control C, Control V. It doesn't like the dollar sign. Probably doesn't like the comma either. Okay, there's my answer to the second question. Okay, so I didn't actually need to do that, right? Apparently it says now do the same calculation with all 40 of Darcy's payments, which I already just did, and then use the sum function to add them together. Okay, and so that's what's going to tell us how much all those payments are worth in today's dollars. Okay, so let's do total. And that just equals the sum of all these previous values. Okay, so I'm going to copy and paste that into the answer here. So you can see it's significantly less than the $1 million that she was advertised to receive. Okay, of course, if Darcy Lynn puts all the checks she receives under her mattress, she'll have $1 million, right? She will have $1 million. The problem is it won't really be worth the same as $1 million it would be today. Okay, and the rest of this is talking about investing her money so that she can actually beat inflation, because inflation is a big drag on your money. Okay, so we want to have the growth rate is 8%, so that should be a constant cell in Excel, which we can do. Okay, it says, what is the minimum whole number percentage of her prize winnings she has to invest at 8% to have $1 million 40 years from now? Okay, we don't have to worry about converting to today's dollar. We just want to see that she's going to have $1 million. Okay, so in other words, she can save it all and have $1 million, but she doesn't have to save it all if she invests it. So we want to find the minimum she has to save every year, what percentage she has to save every year in order to have $1 million. Okay, so interest will only be earned on money that she has saved for a full year, so she gets 0% interest her first year. Okay, and so we look at the examples here. If she receives $10,000, receives 10%, or if she saves 10%, after year 1, she'll have $1,000. In year 2, she'll have that $1,000 plus $1,000 more she saved, plus the interest, which is $80 from the first year. Okay, so this is good to have an example. I provide these examples so that it will help you work through the problem to make sure everything is right. Okay, so let me go. So we have growth rate. We want savings rate or something like that right now. Okay, and so we'll still use this year thing. We'll say amount saved. And we know that's going to be this money, $B, $4, times the amount she saves, which I'm going to put in that. Again, we're going to put dollar signs because we're not going to copy that down. So let's go with 10% for now. Oops, 10% will work better. Okay, so that makes sense. She saved $25,000. So I'll copy this all the way down through 40 years. Okay, I'll put in this column interest earned. And this column will be money in the bank. Okay, the first year we said in the problem, it said she'll earn 0% interest or $0 interest the first year because it hasn't been in the bank the whole year. So we'll just put 0 there. And this money is just going to be the amount saved plus how much interest she earned. Okay, and now we go to our interest earned calculation. She's going to earn interest in all the money she has in the bank the previous year. So this is just going to equal that times the growth rate, right? She will earn $200 in interest that year. And now this money in the bank is going to be the amount saved plus the interest plus how much money she had in the bank last year, right? And so after 2 years, she's going to have, just like the example, $5,200. So I think that's pretty good. If I just copy this down, of course it's not going to work because I didn't put dollar signs everywhere, right? The interest rate needs to have dollar signs. And that's probably the only one. Recopy that. Okay, and that works pretty good. But if we save 10% of our interest, right, it did, or of her prize winnings, it didn't make it up to $1 million. So that did 10% doesn't work. But let's go ahead and go back. We want to put in this example. Okay, she receives $10,000 per year and saves 10% of it. Let's put that in. Okay, I already have the 10%. The first year will be $1,000. The second year will be $2,080, which is what is shown in the example. The third year, it's going to be $3,246.40. Okay, and so that works. And so I'm now pretty confident that my calculations are working here. And this is what you should do too. If you don't get this matching up with the example, then you should really rethink that you've done something wrong, and so that you can't really expect the rest of the calculations to work either. Okay, but so we've proven the calculation works. Now we need to figure out the minimum whole number percentage she has to save to have $1 million. Okay, so I'm going to go back to the original 25,000. So it equals that, divide by that. And so, like I said, 10% didn't work because it didn't give us $1 million. I'm going to jump this up to 20%. Okay, that's over $1 million, so 20% is good. The question is that the minimum? Let's try 19. Okay, we're still good. 18. We're still good. We're getting close though. 17. Okay, she still has $1 million. 16. All right, still has $1 million. 15%. Okay, now she doesn't have $1 million. Okay, so if she saves 16% of that 25,000, so she saves $4,000 a year, invests it at 8%, she'll have $1 million. Plus the 21,000 that she didn't save, she can spend it every year. Okay, so that works out pretty well. So the answer to this question is 16. Okay, Darcy Lynn will have a job in Vegas with earnings. Okay, so she decides to save all of her prize money. So invests 100% of it. Okay, so we just have to change that percentage, right? We put in 16 there. I'll put in 100%. So she's saving everything, right? She will have almost $6.5 million. So I'm going to copy and paste that to here. Of course, it's mad I put dollar signs in there. Okay, and then this is just submit the Excel spreadsheet. I don't need to worry about that. So let me submit the quiz and check if my answers are correct. Correct, correct, correct. 16 and $6 million. Okay, so that is how you would solve this. Again, I hope that helps you see how I'm thinking through a problem like this and how you can think through it. You can see if you set up the Excel spreadsheet well, you should just be able to change a couple numbers up at the top and, completely change the parameters of what you're doing and use this for many different cases.